All right. This video is going to talk a little bit more about properties of logarithms and how we can use them to condense logarithms. Again, we've already talked a little bit about expanding logarithms. If you haven't seen that video, feel free to search through my other videos. But again, condensing logarithms basically is using the same three properties that we have up above here. So again, the logarithm of two things multiplied can be rewritten as the two separate logs added. Well, when we talk about condensing, we talk about going the other direction. So let's think of them more this way. Two logs added together, right? If they're the same type of logarithm, notice they're both common logs in our example here. We can rewrite that as a single logarithm with everything multiplied inside. If two logs are being subtracted, again, that's a single logarithm divided. And again, if we have a multiple in front, right, y times the log of x, then we can put that y up as an exponent inside the logarithm. So again, to condense, we're just doing the opposite essentially that we did from expanding. But now we got to be a little bit careful about order of operations every now and then. So again, to condense the example we have down here at the bottom, I noticed that most of my materials are again inside the logarithms already, but I have two separate logarithms added together. That looks like property number 1 up here. So we're going to rewrite that. Again, notice they're both natural logs, so I'm going to keep that natural log, but I'm going to rewrite that as 6 to the 4th times 6 to the negative 3rd. And in that case, well, we can do some exponent properties there, again, with equal bases multiplied. Remember, we can always add our exponents, right? It kind of goes back to that same property, only in exponent form. So again, equal bases multiplied, add the exponents. This can really be the natural log of, again, 6 to the 4 minus 3, right? Or 6 to the 4 plus negative 3, which basically would be just 6. So again, the best answer we can get without approximating, with hopefully better handwriting than I just gave you there, would be natural log of 6. Again, let's just take a look at a couple examples very quickly, and then we will leave you on your way here. So again, we've got a couple of logarithms. Now I notice I've got logarithms here, and they're both log base 7s. I notice that we have some subtraction going on, but I've got to be a little bit careful here. This is that order of operations thing I mentioned. Notice that this logarithm is multiplied by 4, whereas this logarithm is only multiplied by 2 out in front. So I can't take two simple logarithms subtracted and kind of mess around with that, because I wouldn't know what to do with those coefficients, right? What to do with those numbers in front. But let's go back to our other properties here. Can't we go ahead and put those up as exponents first? So let's go ahead and take a second, and we'll say that this is going to be the log base 7 of, and again, I'm going to say x to the 4th, right? I'm going to put that 4 up as an exponent, and at the same time, I'm going to put that 2 up as an exponent. So log base 7 of x to the 4th, again, still subtracted, log base 7 of y squared. We'll put that 2 up as an exponent as well. Now, you might be saying, well, couldn't we have put that up there as a negative 2, right? Taken that subtraction and said plus the negative, and you absolutely could. But again, that would be addition in between then. And so afterwards, we would end up multiplying these two, and you would have had a negative exponent, and we'd have to do a little fanciness. Maybe I'll show you that here in just a second. I think this method might be a little bit faster, though. Log base 7 then. Now I've got two logs subtracted. I can make it a single logarithm of x to the 4th over y squared. Because x and y have really nothing in common. They don't have equal bases. That is going to be the best we get. Again, your option there would have been saying, well, this could have also been, again, log base 7 of x to the 4th plus log base 7 of y to the negative 2nd. Right, if we put that negative up there along with the 2. But now we're going to end up with a log base 7 of x to the 4th times y to the negative 2. And of course, negative exponents make fractions, right? That's really 1 over y squared, right? Which basically gets you right back to where we ended it the first time around. So again, they both work, but again, if we want to simplify as much as possible, getting rid of that negative exponent is going to happen anyway. Just as easy to do it the first time around, how we did it up there in blue, right, as well. Down here at the bottom, same idea. First thing I notice is I've got that 6 going on. So again, I'm going to say the natural log of x minus 5. Remember, I can't do much about subtraction inside of a logarithm, but we can call this x to the 6th here. And then we're going to call that again a couple of natural logs added together. So I'm thinking multiply on the inside. I've got x to the 6th times an x minus 5, right, on the inside. And again, if we want to get rid of that one extra set of parentheses, we could easily say natural log of, really that's x to the 7th minus 5x to the 6th. I don't know that it really gets you anywhere, but at least, hey, we got rid of one set of parentheses, so not too bad. Hope that helps you with condensing logarithms. Again, be careful of those exponents, or those multiples in front, I should say, that scalar multiple. Make sure we put those up inside first. Then we can deal with the adding and subtracting, right, second, combining or condensing those logarithms. If you have any questions, talk to your teacher. Otherwise, have a great day.